All right. Okay, let's talk about RC circuits. I already botched the first one because I was doing all this writing. So here we go. We've got RC circuits. And RC stands for the resistance times the capacitor. They're all in one circuit together. You got your capacitor here, you got a resistor here, and then you've got a charging voltage here. Okay. And then a switch usually, and then it'll go to another, it usually goes to another device and charges it, and then works as a battery to charge it up. Okay. Where RC is equal is in seconds, and that's your time coefficient. All right. And if it's charging, Q is equal to Q naught times 1 minus e to the minus t over RC. Okay, so we're going to have to use a natural log algebraic thing. Not a big deal. This is for charging. Q is equal to Q naught times e to the minus t over RC. This is for discharging. That's for discharging. All right. So you got to know which one you're doing. All right. And we looked at in class real quickly on Wednesday that if t is equal to 0, then this whole thing goes to 1. And you've got 1 minus 1 is 0. So when t is equal to 0, Q, the charged amount, is 0. When t is equal to 0 in this case, this whole thing equals 1. So Q is equal to Q naught. All right, so we got that worked out. Now let's go to the actual problem. Pacemaker controls. All right, so here we go. The heart pacemaker, 81 times per minute. The capacitor that controls this pulsing rate discharges through a resistance of 2.2 times 10 to the 6 ohms. Usually the resistance is very, very high on these things. Okay, it's very, very high. And then one pulse is delivered every time the fully charged capacitor's loss is at 66.3% loss. So we're discharging, okay? What is the capacitance of the capacitor? All right, so that's what we need. That's what we're going to do. All right, so let me write down R is equal to 2, before I go to my ladybug, 10 to the 6 ohms. Capacitance, we don't know. The time, we kind of know, but we've got to figure that out. Okay, 81, it does it 81 times per minute. So we want to know the time lag between pulses, 81 times in a minute. All right, so let's go to my thing. So if I got 81 times in a minute, how many times in a second does it go? Well, we take times 1 second, 60 seconds. Oh, shoot, I did it again. 1 minute divided by 60 seconds. Within a second, or between pulses, is equal to, it does it 81, so that cancels, 81 times over 60 seconds. And so we get 81 over 60. And that equals 1.35. That means it does it 1.35 times per second. If I want to get 1 second on top, if I want to get the second on top, I've got to take the inverse of this. Okay? So I just take the inverse. You get 0.741 seconds. That's the time between each pulse. All right? That was kind of the tricky part. So T is equal to 0.741. That's just getting it set up. So that's part 1. We'll do part 2. Now we'll do some natural log stuff, and you can see how it works.